This is a presentation on using GraphPad on the internet to calculate either the paired t-test or the independent t-test in the statistical analysis of your data. I am Reggie York. At the end of this presentation, you will be able to use GraphPad on the internet to determine if your data are statistically significant when you employ either of these two statistical tests. This presentation is especially for those who would use either of these statistics to test the hypothesis in evaluative research. I got two examples here that are especially pertinent. One is you have matched pretest and post-test scores for one group of people, or you are comparing the gain scores of a treatment group and a comparison group. This presentation is for these two particular situations where you want to statistically analyze your data. What we will do in this presentation is access GraphPad on the internet, provide instructions on our situation regarding the statistic we'll use. We will enter our data and review the results. We'll now go to the document that you may have. This carries you through the procedures I'm going to go over step by step. It provides the documentation for it. I'm going to use this presentation to illustrate it on the screen so you can see me doing the work. First thing we're going to do is click right here for GraphPad. That should take us to that particular website where we will go through a set of procedures for using the computer in each of these two situations. They are presented together because they're pretty similar with one major change. So in the first screen you can see, which is also on your instructions on that document, is you see Analyze Continuous Data. You see an option that's the default specification is t-test to compare two means. That is what we will be doing. So we will not change the default. We'll leave it as it is. So we don't have to do anything on this step except hit the continue button. Now we come to t-test calculator. T-test calculator. And what it does is it gives us three steps. Step one is choose data entry format. Step two, enter your data. Step three, choose the test. So this one, the first one, the default says enter up to 50 rows. By rows, that means how many either people you have in your groups or how many persons when you're doing paired t-test. If you're doing a paired t-test, when you come down to data, group one will be your pretest score for client number one. Group two on this same line would be your post-test score for that same person, that person there. When you're doing the independent t-test, group one is your treatment group and group two is your comparison group. So let's go here and enter a set of scores. This time I'm going to be showing the paired t-test. The first person had a 12 on the pretest, a 15 on the post-test. The next person had a 17 on the pretest and a 19 on the post-test. The third person had a 19 on the pretest and a 17 on the post-test. That means that that person actually got worse rather than better. Here is a 12 and a 16. Here is a 13 and a 16. So now we have five people for whom we have a pretest score and a post-test score, but five clients. That's our data. Over here, it says, number 3 says choose a test. We are doing the paired t-test, not the unpaired. Unpaired is the independent t-test. Paired t-test is what we're doing. So we're going to hit the button that says calculate now. and this is the result that we will get from that analysis. There are three things in particular I want to bring your attention to. First of all, the two-tailed p equals 0.1292. By conventional criteria, this difference is considered not to be statistically significant because it's worse than 0.05. 0.12 is higher than 0.05, therefore it's worse than. Here is your value of t. And also the three things here is the mean score. I'm sorry, I'm having trouble with this. Here's the mean score down here, 14.6 for the pre-test, 16.6 for the post-test. So this shows that the post-test was better, but as you can see up here, it was not statistically significant. So you got your p-value, your t-value, and your mean scores right down here that you need to address. Okay, that is my discussion of this particular application when you're using the paired t-test. I'm going to go back now, and let's say we are now doing an independent t-test. We are comparing two groups. It's also t-test to compare two means, just like we did before, because that's what we're doing. Up to 50 rows. We keep the default there because we do not have more than 50 people in the group. We will have the unpaired t-test now. That's the default, so we'll leave the default as it is. And let's put some data in here. This is group 1. This is the treatment group. This person's gain was 6. The next person's gain was 8. The next person's gain was 1. The next person's gain was 9. The next person's gain was -3. You can't have a negative gain. Over here for the next group, let's say we have, this is the comparison group. They did not get treated. The first person had a 1. The second person had a 0. The third person had a 0. The next one had a -2. And this person had a 6. So here we have the scores for group 1. These are the treatment group scores, 6, 8, 1, 9, and -3. Over here we have the comparison group gain scores of 1, 0, 0, and -2 and 6. We're doing the unpaired t-test, leaving it there, and now we just hit the calculate now. And you can see up here the two-tailed p-value equals 0.2591. So this data also was not statistically significant. Here is your t-value, and here is your mean scores for the two groups. The treatment group had a mean score of 4.2. The comparison group had a mean score of 1.0. So you see the treatment group did do better, but the comparison group did do better than the comparison group, but not at a statistically significant level. By the way, when you fail to have statistical significance, then of course your data fails to support your hypothesis. Okay, I hope this is beneficial to you in regard to the use of these two particular statistics in the examination of your data.